This is 2011 FRQ number 3. This is now the start of the non-calculator portion. All right. So the R be the region, the first quadrant enclosed by the graph of f of x equals 8x cubed and g of x equals sine of pi x. Well, first of all, you need to figure out which one's f, which one's g. So 8x cubed looks something like this. Sine looks like that. So based on this graph, I would say, well, this is 0. So I would say this is f of x. And then this curve up here is going to be my sine of pi x. That's my g of x. All right. Okay. As shown in the figure above, write an equation for a line tangent to the graph of f at x equals 1/2. So tangent to the graph, so we don't even need g in the first problem. We want the tangent at that point, right? So since I already have the point, that's my xy, the only thing I need, and again, the word tangent should give you the clue that we're looking for the first derivative, because the first derivative would give us the slope at that point, okay? So first thing we need to do is find f prime. So part A, f prime of x is equal to 24x squared. And so my slope is f prime of 1/2 because it's at that point. So 24 times 1/2 squared, 24 times 1/4, that gives me 6. That's my slope. All right, so the tangent line is y minus y1 equals m times x minus x1. I believe you are welcome to leave it like this. You can clean it up. So y minus 1 equals 6x minus 3, y equals 6x minus 2. Okay, and that's it for part A. Part B says find the area of R. All right, so the area of R is easy to go with top minus bottom over 0 to 1/2. So this is dx problem. So the area is the integral between 0 to 1/2. Top function sine of pi x minus 8x cubed dx. All right, so now let's take our antiderivative. Don't forget chain rule here. You have sine. So the antiderivative sign is negative cosine. So negative cosine of pi x. But don't forget you have a pi in here. So because of chain rule and because it's antiderivative, the pi comes out as a reciprocal. So it's going to be negative 1 over pi. All right. And then minus 8x to the 4 over 4, evaluate 0 to 1/2. Okay. That gives me negative 1 over pi. Cosine of pi x minus 2x to the 4th, 0 to 1/2. Okay. All right. So now let's plug it in. You get negative 1 over pi. Cosine of pi times 1/2, so pi over 2, minus 2 times 1/2 to the 4th, minus negative 1 over pi. Cosine of pi times 0, 0, minus 2 times 0, 0. Okay. Cosine of pi over 2 is 0, so that's gone. So that gives me negative 2, 1 over 16, plus, this is 1, plus 1 over pi. So that gives me 1 over pi minus 1/8. That's my area. Okay? All right, last but not least, part C. Write, but do not evaluate an integral expression for the volume of the solid generated when R is rotated about the horizontal line y equals 1. So y equals 1 is up here, right? So then if we're going to rotate it this way, we want dx is going to be washer. And since we have two functions, we have the outer radius going to f of x and the inner radius going to the g of x, all right? So the big radius is the top function of y equals 1, that's your axis of rotation, minus the farthest function 8x cubed. The little radius is still the axis of revolution, but now minus a closer function, sine of pi x. So the volume of this is equal to 0 to 1/2, big radius squared, minus little radius squared dx. All right. Oh, and I forgot pi r squared, right? Okay, that's it.